Okay, sorry, the video cut out right there. All right, so the fractional uncertainty of the answer would be equal to the fractional uncertainty of the individual portions of the calculation. All right, now that's a tricky equation to use, but look, what it's saying is instead of adding the absolute uncertainties to each other, what you need to do is to add the fractional uncertainties. Or you could also, for example, add the percent uncertainties, because remember, fractional uncertainties and percent uncertainties are more or less the same thing. They tell you exactly the same information, just in a different form. So let's take each of these two calculations. Let's do the multiplication. Now, I just wanted to warn you in advance, these answers might come out slightly different. And the reason for that is that the rule is a little more complex for multiplication and division than it is for addition and subtraction. That rule is essentially absolute. It works out perfectly that the formula that we got that said that delta Q is just simply equal to delta A plus delta B, that calculation, or delta X I think we use, delta X and delta Y, that way of calculating it is very simple because they have the same units and you can get away with it. And so the formula produces exactly the answer that the range method produces. Now these will produce essentially the same answer, but there will be a slight difference. So it's through statistical analysis that we could prove that this rule does actually work. And I'm going to put a box around it because this is the rule for multiplication and division. But I just want to remind you, you could always use the range method. Now, in some cases on the IB exam, they have asked questions where you must use this equation. It cannot be done by the range method because they're asking you to use this equation specifically. So what I'm going to do is I'm going to plug in all of the numbers, and then I'll go through and I'll work my way through the algebra. So this is what I want. What I want is delta Q. Okay, I found for my first calculation that I got an uncertainty of 12. So that's what we're looking for to see, do we come up with an uncertainty of 12? Okay, so what I end up with is delta Q over, now realize I know the value of Q because I know the calculation, it was 96, right? That was the answer to the calculation, 18.5 times 5.2. So I know that this guy is 96.2, and that would be equal to delta A, which is 0.6 over 18.5, plus 0.5 divided by 5.2. Okay, so let me bring everything together. I'm going to go ahead and do all this math on the right side, and then we'll do the algebra as a separate step. So 0.6, divided by 18.5 plus 0.5 divided by 5.2. Okay, now here's the deal. That number right there is the fractional uncertainty for the answer. Because look, it's equal to delta Q over this, right? This is the fractional uncertainty for the final answer. And I know that it's now 0.1285, or in other words, it's about 12.9%. It's about 12.9% uncertainty in the measurements based on these two numbers that we used. Now, let me write that down. Delta Q is equal to, or 9 over 96.2 is equal to 0.128586. All right, so then how will I get the delta Q by itself? Well, it'll be like this. I'll say delta Q is equal to 0.128586 times 96.2 to give me a final uncertainty, the delta Q, that's my absolute uncertainty, of 12.37. Okay, 12.37. Let me just show you. 12.37. That's what we got from the range method, right? So this formula is quite a bit more complex. It's more challenging, but it's required in order to be able to do this. What we essentially do is turn these into percent or fractional uncertainties, and then we use that to multiply by the answer to the calculation to figure out, okay, well, how uncertain is this multiplication calculation? So delta Q is equal to 12.37. Same exact answer that we got from the other one. All right, let's take a look. So that worked out great. That was basically perfect. Let's see what happens when we do the division. That says that delta Q over, now remember, this was a different calculation. So this is 3.55769, and that is equal to 0.6 divided by 18.5 plus 0.5 divided by 5.2, right? Because I use the same numbers. Right? I made the two calculations using the same numbers. So I already know what this adds up to because I've already done this I've already done the math. It's 0.128586, and that is equal to delta Q over 3.55769. So therefore, delta Q would be equal to 0.128586 times 3.55769. Remember, our answer for that one was 0.46. Let's see what we end up with here. 0.128586, let me move over a little bit, times 3.55769. 0.4574. So therefore, when I cut this thing down to 2 digits, it will either be 0.46 or it will be 0.5, exactly as we got with our other calculation. So that formula is quite challenging to work, and what I would recommend is try the problems both ways. Do it by the range method, establish what the answer is, and then make sure that that equation works and that you understand how to plug everything into that equation.